Question 9. So this is a geometric sequence, so therefore the second divided by the first must be the common ratio, as must the third divided by the second must also be the common ratio. So they both must be equal to each other. So the second divided by the first must equal the third divided by the second, because both of those are the common ratio. So that really is our starting point for part A. So multiplying out, that gives us this pair of brackets which I've then expanded, taken it all over to the left hand side, and that gives us what we had to show. Now for part B, we've got to show that k equals 9 over 11, and we're also told that k is not an integer. Well, this probably does factorise, but I think it's a pretty tricky one to try to factorise. So I've just chosen to solve this using the quadratic formula, with a being 11, b minus 130, c being 99. So I've used the quadratic formula over here, which gives me two solutions of 11 or 9 over 11. K is not an integer, so therefore I've shown that k must be 9 over 11. Now for part C, I've got to evaluate the fourth term of the sequence, giving your answer as in a fraction. I need it for a bit later on. I need it for part 2, so I'm not just going to go from the third to the fourth. I'm just going to pop down all the terms. So given that k is 9 over 11, my first term in the sequence is going to be 7 lots of 9 over 11 minus 5, which is 8 over 11. The second term in the sequence is going to be 5 lots of 9 over 11 minus 7, which gives me minus 32 over 11. And my third term is going to be when I substitute 9 over 11 into this, which is 128 over 11. So those are the first three terms of this sequence. Dividing the second by the first, I can see that my common ratio is multiplying by minus 4, as it is dividing by the third by the second. So my fourth term, I just take my third term, multiply that by minus 4, and it gives me minus 512 over 11. Now for C part 2, evaluate the sum of the first 10 terms of the sequence. So for that I'm going to use the summing formula which is given. So the sum of the first 10 terms is the A, which is the opening term, which I've just worked out to be 8 over 11, multiplied by 1 minus the common ratio, so minus 4 to the power of 10 on this occasion, and so the 10 terms in the sequence, and that's all divided by 1 minus the common ratio, 1 minus minus 4, which is obviously 1 add 4, which is 5. So popping that all into your calculator, being ever so careful to protect that minus, so make sure you put that minus 4 to the power of 10 inside a bracket, we see that the sum of the first 10 terms is minus 152,520.